Hey there, this is Adam again, and let's talk about storing data, because one of the most important and critical tasks during the first stages of the project is picking the right storage solution, and in Azure, one of the most powerful ones are storage accounts. Today we're gonna get introduction into Azure Storage accounts, so without further ado, let's jump straight to it. So let's talk about Azure Storage. Azure Storage is a highly scalable service in Azure, allowing you to store data objects, files, messages, but it also can be your NoSQL database. You use it because it's durable, meaning that Microsoft is handling all the hardware failures. It's secure because all the data is encrypted. It's scalable because it can handle all kind of data up to petabytes of data. It's managed by Microsoft. It's also accessible because there's a bunch of APIs and SDKs allowing you to connect to Azure Storage. So what services are part of the storage account? There are currently 4 services that are part of it. There's Blob storage, file storage, storage queue, and table storage. So the first one is Blob storage. Again, this is highly scalable service for text and binary data, which means any kind of file that can be put there. So it's ideal for pretty much any scenario, from hosting video files, distributed access, documents, backups, pretty much anything. The structure of the blob storage is very simple because blob storage is separated into something called containers. Think of containers like your partition on a drive. It's the entry point for your data. Each container contains 1 or more files. And this is it. It's just a flat hierarchy of files on your service. There are multiple access tiers on a blob storage. Currently there are 3. It's hot, cool, and archive, where they're optimized for infrequent and frequent access. The hotter the storage, the more frequent access you would expect, but also the higher the cost. The cooler the access, the cost lowers, but you also pay additional fee for retrieving the data. An archive is amazing, cheap storage for a lot of data, but also the one that you use if you don't expect your data to be retrieved at all. So it's ideal for very long-term backups. The next one is file storage. File storage is a service that allows you to create shares in a cloud, and that's pretty much it. Because again, the structure is very similar, except of containers you have shares, and in shares you have files and folders. Notice that you have folders here because Blob was flat hierarchy. In this one you actually have file share that are POSIX compatible, which means you have also files folder and a hierarchy. So what would be the difference between the file storage and blob storage? When should you use one? I would say, in my opinion, it's very simple. If you need file shares and you're doing lift and shift scenario, go for file storage. Otherwise, always go for blob storage and design for blob storage. It's much more mature service and much better to deliver all kinds of services. You just need to design for it from the start. The next one, you have storage queues. Storage queues is a middleware kind of service because it's delivering cross-service communication through messaging and events. Storage queues are separated into queues, and each queue consists multiple messages. There's no more than this into this service. It's just a simple messaging service. The next one is table storage. This is your NoSQL database in a cloud, the most simple one and the most basic one that you can use, but it's also very good and highly scalable like other services that are part of the storage account. Storage tables are separated into tables, which each contains rows of data, and there's not much beyond this. It's just a simple NoSQL database. So what are the core features of the storage accounts? The first one is performance tier. There are 2 performance tiers. First one is standard. The standard is used for all kinds of services within the storage account, but there is also premium, which is used only for unmanaged virtual machine disks. So I guess there's not a lot of choices for the developers and the architects here. because you always use standards if you use the services that are the most common for the storage account, and if you use unmanaged disks, then you use premium. The next one is very important one because it's a data redundancy. This is the key feature that allows your data to be durable and highly available on the storage account. So the first one of the data redundancy is locally redundant storage. So it's a low-cost replication strategy, but it's very simple one also. When you save your file into Blob storage, it is saved on something called scale unit, which synchronously copies your data into 3 locations. So you have 3 copies of your data at all times. Each copy is saved into something called fault domain and update domain. Since they are on separate update domains and fault domains, your data will be always available, even in case of hardware failures or updates. The next one is zone redundant storage. This is a bit more pricey, but it's still very inexpensive, because your data is being saved synchronously into 3 separate scale units into separate availability zones. Separate availability zones means that you have a separate power source, separate cooling, and separate networking, but you also maintain 3 copies of the data. The third one is geo-redundant storage. This storage is just like you would combine 2 locally redundant storage in 2 regions. The second region that is part of this architecture is something called region pair. So if you would deploy your data into North Europe, the region pair for North Europe is West Europe. You cannot choose it, the region pairs are there by default, and you can check what is the region pair for you in the documentation. In this scenario, you have 6 copies of the data, and your data is copied asynchronously throughout the regions, but within the region it's synchronous copy. Lastly, you have read access geo-redundant storage, very similar to the previous scenario, except in this scenario you can actually read at all times from the second region, because in previous example, in geo-redundant storage, you would not be able to read data from the second region unless Microsoft would initiate failover. Next, you have storage APIs and libraries, because your storage account can be accessed through REST API. Pretty much any service that you've seen so far can be accessed through REST API. But also you have a lot of client libraries for many popular programming languages like .NET, Java, Node, Python, PHP, Ruby, or even C++. So let's go into servers and do some demos. In the portal, in order to create storage account, you go to this create resource, type in storage account, but also if you see, storage account is also here available very quickly. So click on it. So what you need to provide is the resource group. I already have one created for me. You need to provide the name. Notice that this is public DNS, therefore it needs to be unique globally. The next one is location. So I'm gonna leave it as North Europe. It's the closest data center to me. Performance, we were talking about this, since we're not working with the unmanaged disks. We're gonna go for standard. There's something we didn't talk about, which is account kind. And I didn't talk about this on the purpose, because I strongly believe that you always should use storage v2, because other ones do not really bring any benefits or any additional services. They're actually older versions of the service, which means they're less flexible, have less features, and usually cost more. So just go for storage v2 always. And choose the replication. In our case, I'm just gonna choose the most simple one, which is RA-GRS. And what is the default access tier? Since we're gonna be using the storage a lot, I'm gonna pick hot, because I'm gonna be putting a lot of files in here very quickly. So hit review and create, and hit create. The deployment of the storage account takes about a minute or 2, and it's ready to go. So let's speed this up a bit. So the deployment is done now. We can go to the resource. Let's hide this shiny pop-up. And this is how our resource looks right after deployment. So let's go through the portal features that allow us to work with the storage account. So we'll go back to my presentation and talk about the portal features now. So first of all, you have Overview tab. Here you have your most basic and most important information about the storage account, like the name of it, replication, account kind, performance tiers, but also short links to your services that are available, like blob, file, queue, and table. Next, you have Data Transfer. In this tab, you can give your estimation of the data size that you need to move to the cloud, what is your network bandwidth, and the transfer frequency. And Microsoft will recommend you what tools should you look at to transfer this data effectively. Pretty cool feature if you're starting with the Azure and starting with storage accounts. Next, you have Storage Explorer. Because Microsoft created something called Microsoft Azure Storage Explorer, a tool, a desktop tool that allows you to manage blob storage and storage accounts through nice UI, and they recently started migrating this to the cloud, and this is Storage Explorer. In here you can manage all your data, all your queues, all your tables and file shares effectively, but remember, at the time of this video, this is actually still in preview, which means it's beta, so it can be a bit funky sometimes. In the settings, you have something called access keys. Access keys is the name of your storage account, but also two keys that are administrative keys to the storage account. Be sure to very nicely secure this, because having access to those keys gives someone administrative access, so they can actually create or actually delete everything. Next is CORS. CORS are headers, cross-origin resource sharing headers. So if you're developing single-page applications, you can actually give access to blob storage APIs from the JavaScript level. Configuration tab allows you to change some of the most basic and most important stuff about the storage account, like SSL, access tiers, or replication. Shared access signature is similar to how access keys work, except you can actually fine-grain permissions here. So you can say that when generating stored access signature, which is very long key, this stored access signature will only have access, for instance, to blob storage. The only services that will be available from this blob storage will be, for instance, service and object. And what are the permissions that user who will have this key will be able to perform, like reading, writing, listing. You can also even specify what is the duration and allowed IPs for this key to work. It's a very cool feature if you want to give access to external parties without risking giving them delete access to your data. Firewall and virtual networks allow you to specify from where and when someone can access your storage account. Currently, it's either by IP, or you can set a virtual network integration. So any traffic coming from your virtual network will by default be allowed to connect to this storage account. Static Websites Blade allows you to configure static website hosting, because one of the major scenarios for public blobs is to host websites. If you're developing single page application, you can actually set it up here so that you host it directly from your blob storage instead of actually employing an entire server. Properties tab gives you most important information about the blob storage with additional some key information that are a bit more detailed. That's why it's not part of the overview tab. In the blob service tab, you manage your blobs. The first one is blobs blade. In here you can create containers, but also manage your files from the portal itself. You also have custom domain. So if you need to connect your blob to the custom domain, because maybe that long URL is not something you want, especially in the case of single page application, this is where you do it. You have soft delete. So if you're afraid your data might be deleted very often, but you want to contain like a versioning, snapshots of that data, then you enable this soft delete here, and you will maintain all the versions of the file. But be aware that you're also gonna pay for all the copies of the data. Lifecycle management is a very cool feature because we were talking about those access tiers, hot, cool, and archive. Lifecycle management allows you to configure so that blobs are automatically moved from hot to cool and from cool to archive and then deleted based on the modification date automatically. Next, you have file service. In file service, of course, similarly to Blob, you manage file shares and the files within the file shares. You also have tables, so you can create tables, but actually, I very quickly skipped this, but in the portal, you cannot manage tables other than just creating tables. To do that, you need to use Storage Explorer, but the desktop version. And the last one is queue service. In here, you just manage your queues and the queue messages. So let's go into portal. Since we created this, let's go through the Storage Explorer. So in the Storage Explorer, you can use it in the cloud by clicking here. You will get this panel. You have your blob storage, file shares, queues, and tables. Of course, right now everything is empty because I just created the service. So you can right click here and create new share and give it a name. I'm gonna call it demo. There's something called public access level here. I would say by default, keep it private. Private means that there's no anonymous access, giving you opportunity to secure data out of the box. Private access means any client connecting to the service needs to provide either access key or shared access signature, or can authenticate through Azure ID. Blob and containers means that access to this blob will be available from the public without any kind of authentication. So let's leave it as private. So if you go to the demo container that we created now, you have this toolkit here. So let's hit on upload and let's upload some file. Hit upload and it's there. So as simple as this, you just upload that file into your storage account on the cloud and it's right now stored there. So let's hit on properties of this file and let's copy the URI of this file here for a minute. So if I'm gonna copy this file, I'm gonna lower this window, open new tab and hit enter. Notice that it says this resource was not found because our private container does not allow authorized access. It doesn't even say that there's a file like this for security reasons. But of course, if you would create new container that would be private, or actually blob, not private, and let's call it public. When you upload file into the public container, those files will be available for public access. So if we hit properties again and copy the URI and open the browser, we were able to get the file. So let's close this panel. And similarly, you can actually create file share, queues, or manage tables. But this tool is not as powerful as the tool I wanted to show you, which is the desktop version of this tool. In here, you can connect to your storage account and manage it much more effectively. In order to connect here, you need to do one of the couple things. You can connect through stored access signature, or you can connect through access key. In this demo, I'm gonna use I'm gonna use access keys. So I'm just gonna grab this connection string here and put it here. So I'm gonna hit on add account, connect through use connection string, hit next, paste in the connection string, hit next, and connect. So in just couple seconds time, I'm connected and it says I'm connected through the key and I'm able to manage my services. As you see, I'm able to see the containers that I just created, but I'm also able to create new file shares and manage files here. I can upload folder or I can upload file. I'm gonna upload like, let's say, license file. Why not? So now I have some file uploaded on my file share. But what I want to show you is that you can actually mount this share, since this is a Windows share, by going here into File Service, Files, hitting on your share, and there's a very cool Connect button here. This button allows you to see what are the commands that you need to run on each system to connect this to this share and mount it as a drive locally. So next, I guess we have the table service. As remember, you can only manage tables in the Storage Explorer. In here, you're just gonna see the tables and a queue service. So let's go back to the Storage Explorer and go to tables. I'm gonna right click and hit create table. And I'm gonna call it, I don't know, demo. When you create table, it always has two columns, partition key and row key, and you can start adding rows. Of course, you need to supply some information here. But notice that I'm not adding any actual data yet. To do that, you can actually just add a property, call it a name. Maybe add a surname. And hit insert. It is interesting to notice that all the previous columns are null right now, and this is because there's no SQL and there's no schema that you can actually manage here. And lastly, we have queues, so let's create a queue. I'm gonna call it a demo, and queue is very simple because it's all about adding messages. So you can add a message, add a message, add a message, and that's it. There's nothing else. It's about putting those messages in and dequeuing them from the external services so they are being processed. So since this is covered right now, we can go back here and say that's it for today. As you see, storage accounts are great. You have multiple services, scaling, redundancy, multiple tiers, and a lot of features. You can quickly integrate them in multiple applications, services across multiple clouds and get all of those features at pretty much no cost. So I guess that's it for today. So if you like the video, hit thumbs up, leave a comment, let me know what can I improve. And if you really liked it, subscribe, and see you next time.